Welcome to this episode. In this episode, we will learn the mobility and electrical conductivity of metals. We know in the metal, the outermost electrons are loosely connected to the ions, and these electrons can move randomly and freely within the metal. The metal is some sort of crystal structures and crystal lattice kind of thing. That means the metals are basically regularly arranged atoms, and within that, electron can move. And these electrons will behave like molecules in a gas. We often call this free electron model or free electron gas model. And we can imagine the electrons are moving in a solid and ions are fixed in space, and electrons are colliding with ions and other electrons with solids, and therefore their free path is limited by the collisions. And the free path traversed by the electrons between two successive collision is called the free path, and average of all these free path is called the mean free path. And the average time between two successive collision is called the mean free time. Now, if we apply the electric field to this metal, the electric field will accelerate the electrons, and due to collision with stationary ions and other electrons, an electron will lose energy, and after some time the electron will acquire some steady average value in the velocity, and that velocity is called the drift velocity. Basically, the electrons will move opposite to the electric field because electrons are all negatively charged. Right now I am ignoring the negative charge. I am calling the charge is Q. Sometimes electronic charge Q is written as E, only the magnitudes. They are similar. Therefore, the acceleration is the force by mass. Here force is Q into E divided by the mass of the particle. That means in this case that is electron. Therefore, the t is the average time between two successive collision. Therefore, the velocity acquired by the particle is velocity equals to acceleration into time, a into t. The acceleration is q e by m multiplied by t. And we call the q and electric field is constant and mass is constant, then Vd equals to mu into E. Mu is basically the mobility of the electron. That means it's a proportionality constant. That means if you apply the higher magnetic field, the velocity will be higher. That means drift velocity is higher, and it depends on the factor mu. It's called the mobility. Therefore, the drift velocity is proportional to E. And now we turn to what is the current density in this system. Suppose we are considering a metal bar is connected to some battery. That due to this battery voltage V, the electric field established here, and the metal is metal. The length of the bar is L, and number of electrons within that is total number of electrons, that is N, capital N. And whenever you apply electric field, apart from the random motion, there will be superimposed the drift, and the current is basically N into E. Here electronic charge is denoted by E without the negative sign. N into E is the total charge, and it takes t time to travel from this end to this end, then Ne by t. The current is Ne by t. And t is basically the length of this bar or rod, whatever you call it, divided by the velocity of electrons, L by Vd. That means Ne multiplied by V suffix d divided by L. And we know what is the current density. Current density means the current passing through a wire or some bar or some rod divided by the perpendicular area. That means if this is the bar, this area is to be considered. The electron flow is something like this, and area is basically perpendicular. That means area vector is basically parallel. That means the area is perpendicular, but you cannot take this area like this. Here I considering this area of the bar is A, that is I by A. current divided by perpendicular area of cross section. And I is NEVD by L. You put that value of I, NEVD divided by L into A. NEVD and L into A. L is the length of the rod and A is the area, that means the volume of the rod or conductor. And NEVD and N divided by V is the number density. Here N is the number density, that is N by V, number of electrons per unit volume. Therefore J equals to NEVD, and we called N into E. N is the number of electrons per unit volume, E is the electronic charge, magnitude of the electronic charge rather, and that is the rho density, that is called charge density. You can call this is J equals to rho into V. And J equals to NEVD, and VD is basically mu into E. And this is a constant basically for a particular metal. N is the number of electrons, E is the electronic charge, and mu is the mobility, and we call this sigma. This sigma is called the conductivity of the metal. It depends on the number of charge elements, number of charges, charge particles, and electronic charge is constant, and the mobility of the electrons. And this equation is also known as the Ohm's law. Thank you for watching.